In this question, we're given the diagram of a right triangle, the right part meaning that there's a 90-degree angle in it. And we're asked to determine which of these equations correctly shows the relationship between the sides of the right triangle. Well, we know that the relationship between the sides of a right triangle is given by the Pythagorean theorem, which says that x squared plus y squared equals r squared, where x is one of the shorter sides, y is another short side, and r is the long side, or the hypotenuse, the side opposite the 90-degree angle. So we'd say that the 0.25 would be y, and the 2 here would be r. So let's plug these values for y and for r into our formula. And when we do that, we'd get x squared plus 0.25 squared equals 2 squared. Then what we have to do is solve or rearrange this equation for the unknown variable x. So first, let's move this 0.25 squared to the other side. And so what we'd have to do is subtract 0.25 squared from both sides. So that would cancel on this side, and we're left with x squared equals 2 squared minus 0.25 squared. Next, we have to get rid of the squared here to get x by itself. So we do the opposite operation. So the opposite of squaring something is taking the square root of something. So we'll take the square root of the left side, and we'll take the square root of the right side. And when we do that, the square and the square root cancel, leaving us with x equals the square root of 2 squared minus 0.25 squared. And when we look down our list of options, we see that D is the right answer. That matches our solution. And there you go. Now there's just one thing we do need to point out. Is you'll notice here when we took the square root of x squared, it just became an x. Well, we can't do that on the right side for the 2 squared and the 0.25 squared because they are subtracted from one another. That's why B is not the right answer. To demonstrate that, let's take a look at something like 2 squared plus 3 squared, and we take the square root of that. If we did a full solution, we would end up with the square root of 4 plus 9, which equals the square root of 13. Now, if we compared that to trying to do it another way, in this case, if we thought that the square root of 2 squared, if we just canceled that, that would end up with 2, and then the square root of 3 squared was 3. If we look at that, we can see that 2 plus 3 is equal to 5. And so we know that these are not equivalent. Therefore, we can't take the square root of individual terms when they're added or subtracted from one another. And that's why the correct answer is D.